Good morning. We're here with Emerson for digital transformation and innovations for safety in refineries and chemical plants. Today, we'll be talking about the digital transformation elements of safety and environmental. The Biden administration is very much focused on environmental justice. But what does environmental justice really mean to us in our daily lives at a chemical plant or a refinery? And where that ties in is at the fence line. So fence line monitoring is what's going across your fence line goes into the community. And with the digital transformation, rather than finding leaks or other things that cause leaks, very much through on the safety side, after scheduled inspections that occur 90 days out, 60 days out, the digital transformation uses measurement and sensing to find those things in real time. So environmental justice, which you'll hear a lot about and is a big driver on the EPA OSHA side, comes down to reducing what's going across the fence line, which ties into digital transformation because we want to find these things real time through measurement and sensing rather than finding them after 90 days or 180 days or a year through technician-based inspections. So that's what the digital transformation encompasses, how it ties into the current environment of environmental justice, and how measurement and sensing is really part of the answer to both of those questions to improve safety, reduce emissions, improve operability, improve mechanical availability, and if you're a refinery, improve your Solomon index. And if you're in a chemical plant, also just to get to that top quartile. So go to the next slide. Are we ready for the next slide? This is a part of 3 webinars. The first webinar today, we'll be talking about occupational safety and some of the elements that tie in, like personal location awareness, manual sampling. The day 2 is talking about corrosion, fire safety, tank safety, hydrocarbon leak detection. So this is a 3-part series, and this will all be available at the 4C conference in a more detailed format. There we'll have about 8 hours worth of content on this same set of subjects that we're going to cover in about 3 30-minute sessions here over the next 3 days. And with that, I'll turn it over to Emerson.
Okay, thank you. And this is Doug White, and I'm going to talk a bit about Emerson, just for those of you who may not be fully familiar with it. I would be surprised if I went to your plant and we didn't have an Emerson device there. Emerson has a very large portfolio of field devices, and it's continually expanding that portfolio. And as I said, it's very widely used around the world and across all major process industries. Now, kind of 2 developments that we've been working on in the past few years in that area. First of all, predictive diagnostics. So almost all the devices now will self-monitor, and they will indicate if the device is having some kind of a problem or error so that you can take action, replace it early, and not have something that's sitting there not working properly. And the second thing is to add wireless capability to all of these devices. So we can now go into plants and install most of the measurement devices without having to pull wires into the plant. And this has been a big change. It means that we can put in new instrumentation in places we couldn't before, and that we can put it in very quickly. Now, all this instrumentation is producing a lot of data. So if you look at the next level up, the next area that Emerson has been investing is in machinery and software and devices to take that data and collect it and then analyze it and give some basic information about the device itself. And then the top layer is pulling all that together. When you have all of this data, how do you manage it? How do you put it in dashboards so people can use it? How do you alarm on it? How do you build digital twins to monitor the plant? How do you do all the things that you want to do, including remote monitoring and asset management? So Emerson has been continually investing, and it has, as I said, this very large portfolio. Next slide. Yeah. So when we have a safety incident, one of the things we want to recognize is there are at least 4 major areas where the safety impacts the plant. First of all, we have the possibility of serious injuries or recordables, occupational safety. We have environmental. We can have loss of primary containment and government reportable events and notice of violations. We can have community impact, either evacuation alert, shelter in place, or road closures. And we can have a financial impact, either direct losses from the safety incident, production losses, civil suits, and high loss insurance rates. And last week we had an incident at a chemical plant in Illinois, which probably addressed all 4 of these. Fortunately, there were no serious injuries or fatality associated with that plant. But we did have a community evacuation alert. We had loss of primary containment, and I'm sure there's going to be insurance issues and production losses as well. Next slide, please. Here are some statistics. Okay, this is from the European Center on Operations. And this is safety statistics from 2018. And basically the number of tier 1 process safety incidents. Again, tier 1 and tier 2 are loss of primary containment, and tier 1 are the more serious and more expensive ones. So equipment reliability was at the top of the list. And if you go down the list, you see procedures and inspections and other items where improved measurement, as Steve said, can make a big impact on our ability to detect these problems early and avoid these kind of process safety incidents. Next slide. So the API, the American Petroleum Institute, and the American Fuels and Petroleum Manufacturing combined together to put together a safety program for their plants. And they have a very extensive database of all of the safety events and near misses that have occurred in about 95% of the refineries in North America and about 70% of the large petrochemical plants. So this is a really good database to look at where the problems are occurring. And again, the most serious problems are the tier 1 and tier 2 safety incidents. And you can see that the biggest cause by far is piping. And in general, that's due to corrosion. So we're going to talk about corrosion tomorrow in terms of how we might correct that. The second biggest cost is tank overfills and overflows. And again, we'll talk about that as well. Then you can see also that pumps and heat exchangers and fired heaters and pressure vessels are the next major levels. So if we want to impact safety, of course, we've got to have an impact on these major areas of problems. Next slide. So let's look at the same data, but for refineries, let's look at where the major incident losses are. And so the number 1 cause is, our number 1 area is tank farm and storage facility and offsites. And I think that applies in chemical plants as well. And we looked at the next biggest area that turns in refineries to be crude units, and then you can see other process units as well. So there is a lot of data out there that tells us what we need to be focused on and what areas we need to be concerned about. Next slide. Now, this is some information on process insurance claims. So these are major claims, and these are claims more than $50 million for refining and petrochemical plants. Now, if you look at the chart on the left in your screen, that's the losses in refining. And if you were to plot those losses over the years, the trend would not be one you would be in favor of. It shows that the losses are increasing. And there were billion-dollar losses in 2018 and 2019. So what does this mean? And on the right-hand side, you have the petrochemical losses, and you can see again that there have been major losses over the years, including the large one in Pasadena in 1989. But what has been the result of this? The result has been that insurance companies are now raising their rates for insurance for plants. They are increasing their deductibilities, and they are placing caps on their liability. So all of that is making losses a more expensive proposition for plants. And one of the key things about these charts are these are just direct costs. This is material and labor, and production losses are not included. So production losses are additional and can be equal to the direct losses in many cases. Okay, next slide. So when we talk about how digitalization can make the plant safer, one of the ways of looking at it is in the Swiss cheese model, where, for a major safety event to occur, the holes in the Swiss cheese have to line up. And the addition of digitalization and some of these automated things we're going to talk about allows us to place more blockage in the Swiss cheese. And so basically, we can improve staff training and procedures, automated equipment maintenance and monitoring practices, alarm systems and basic process control, safety shutdown systems and relief systems. Next slide. So this is an example of where Emerson has been investing to help improve safety. We mentioned all those areas which are of primary interest. And so in these areas, Emerson has been developing new measurements, new technology, and new monitoring software to be able to determine when this has occurred. And we're going to be talking about several of these areas today and tomorrow in terms of applications. Next slide. Okay, next slide, Ed, please. Okay, one of the primary ways of keeping people safe is to keep them out of hazardous areas. And so one of the things that is an improvement then, instead of operators going out and doing manual checks, if we put automated measurements on the areas of concern, then we can significantly reduce their exposure. Now, this has been particularly important in the last year because we have seen many plants reduce their on-site manning levels, and that basically reduces the time that's available to conduct manual rounds. We want to do that without increasing the risk of breakdown. And so the way you do that is by putting in remote measurements that will enable us to detect these problems. And as Steve said, when you put in these new measurements, you have a continuous measurement of the issue rather than something that has only occasionally checked with manual rounds. Next slide, please. So the benefits, of course, if you don't have to do those manual rounds, you can actually spend your time doing something that's a higher value task. The measurements are more consistent. I have been in many plants where you look at the manual rounds and the data, and the data remarkably stays exactly the same measurement for many days and many weeks. Okay, which indicates that really it's not being done. Continuous monitoring enables us to detect problems early. And again, as we've said earlier, this reduces the need for operator exposure to plant hazards. Next slide. So what's the solution to that? Well, we help many clients go through and look at what are the current manual rounds and evaluate the criticality of the measurement in terms of importance, and then help them make a decision on what it makes economic sense to do to add additional measurements to replace those rounds. And so this matrix is one of the ways we do that. We identify the monitoring priorities and classify them in one to 5. And then obviously the highest priority measurements that will have the biggest impact on and are the biggest safety hazard are the first ones we go after with remote monitoring. Next. And here is an example of some specific measurements. We have a check on the individual measurements. And as I said, we determine the priority based on safety, environmental, and production risk, of course. And then if we look at what might be available in terms of a sensing measurement to go in and replace that manual round. And incidentally, what are listed here are several in the cooling tower. And that's, again, primary area. We find often that operators are reluctant to go into the cooling towers because it's cold, it's wet, and it's slippery. And so putting in remote measurements in the cooling tower is certainly something that's very widely done. And next. I mentioned wireless before, and this is just an example of the wireless products that are available. As I said, these can be installed without pulling wires into the plant to be able to do the measurement. There is a complete portfolio of these measurements, including normal pressure, temperature level, vibration, discrete measurements, toxic gas measurements, and corrosion. So this portfolio has been increased rapidly over the past few years, and it's continuing to be increased. Next. So the 5 steps to implementing the automated rounds are, again, this is just a common sense approach. We review the checklist, we collect the rounds, list of measurements, we list them in the application matrix, we look at the measurement type, we look at criticality and risk and rank, and then prioritize what needs to be measured. Then we work as a team to prioritize the measurements that are to be automated, confirm their connectivity and range, and determine the gateways. These would be the wireless gateways that would take in the measurements. And then provide a quote for what would be the prioritized deployment plan. Emerson has the team to help deploy the wireless in the plant if you are short of personnel. And we also have extensive training classes that can train your staff in how to do that themselves. Ed, next. So again, this is a repeat of that. You might go ahead and build that, Ed.
Oh, that's it.
Okay, that's it. Okay, we'll continue on to we've covered that. Why don't you go ahead to the next slide?
Okay.
Okay, and you can take over from there.
Okay, great. Thanks, Doug. So this is kind of a extension of what Doug was talking about. So this is about replacing manual sampling. We pull a lot of samples in refineries and chemical plants for quality and various things. So this subject is about replacing manual sampling to get people, out of the field, pulling process samples and so forth. So we have a couple examples here of different ways that can be done. So the idea is, limiting the exposure of people to hazardous chemicals, keeping people out of the field. And then also the whole idea that there's, and Steve was talking about this before, the lags of time between taking a manual measurement or a manual sample. And then to sample, you also need to break process seals and let part of the process out into your sampling containers as well. So that can cause some risk. All right. So today, with modern multivariable instrumentation, a lot of these sampling things can be done in an automated sense, where they, a long time ago, many of these measurements weren't sophisticated enough to do that. So the kind of applications we're talking about is things like acid strength, concentrations, densities, viscosities, purity, that type of thing. So there's a chart here you can see. I won't go through every individual measurement, but many of these measurements, things like Coriolis mass flow meters, can measure mass flow, density, temperature, and give you automated sampling data as a result. All right, so let me show you a couple examples. So here's an example of one of those applications. And so a common thing in refining is tank dewatering. Water gets in the tanks, and then you need to drain it off. And this is a lot of times done manually. You drain off the water until you get to the emulsion or the oil, and you do that in a manual sense. So we've been able to automate that procedure using Coriolis, micromotion Coriolis flow meters and density meters as well. And as you let off the water and part of the emulsion, you then see the change in the signal, and then can stop letting the fluid out of the tank. So that's an automated way of doing dewatering. We've got a lot of good references on this particular example. I'll show some of those at the end. Another one is in automatic sampling is concentration, density, and concentration. This is an example of an Elke unit in a refinery. And the idea here is to online measure the acid strength through a Coriolis meter instead of taking a manual sample. And you can see from the chart, they're plotting the acid strength from the Coriolis measurement against the lab measurement, and you can see they track very closely. So a lot of the sampling the frequency can be increased, which improves process control, but then also you reduce safety risk by keeping people out of harm's way in doing that. Okay, so that's that one. There's one more, and this is around smart meter verification. It can take, so traditional methods of verifying meters include you taking the meter out of service and then calibrating it offline in a laboratory. So we've designed electronics and diagnostics so this can be automated. So you can go through the whole calibration procedure and check the health of the instrument and accuracy online and have measurement confidence in the end as a result. So this is a way of automating that procedure as well. Okay, so these are all good. These were 3 examples. And then these are the references. We've got some very good references for a lot of these things. The first one is from Shell. This is the dewatering one I was talking about, the first one. So they've used this to dewater these tanks. And So we have one at Shell. We've got them at several other refineries in North America that I know of as well. So that's a good one. And then the acid concentration. Now this isn't specifically an Elke unit, I don't believe, but they were monitoring acid strength at Equistar, and they wanted to be able to do it in an automated sense. Oh, it is an alkylation process. I apologize. And so they can monitor the acid concentration in that unit using the Coriolis meters, and then reduce that reliance on manual sampling. And then the last one's Dow Chemical, and that's the smart meter verification. They've adopted smart meter verification as their standard procedures, and they talk about how they are eliminating human factors as a result and improving safety through doing that also. Okay, so that's the three references. Okay, the next solution is around personnel location awareness. So knowing where people are in the plant when there's an incident is very important. And so there's three areas here that we focus on with this solution. One is keeping people's contractors and employees safe. Knowing the zones of the hazardous locations. So you may not want people in specific locations, so you can track keeping people in areas that they should be. And then in the middle one, in an emergency, you want to know where everybody is. I mean, the procedures without this are quite manual. People have to check in at their mustering points, say, okay, I'm in a safe area. So we'll talk about that as well as to how to automate this mustering as well and understand where people are. And then fallen personnel. So if somebody gets injured in the plant, to be able to quickly respond to them in an emergency situation. Okay, so commonly there's barriers to this personnel safety. There's a lot of technologies out there to track people. I mean, we all use the GPSs on our phones for driving and so forth, but a lot of these technologies aren't suitable for industrial environments. And so an industrial location requires a lot more sophistication and better engineering and design. And some of these solutions can get quite expensive as well to monitor where people are. So Emerson has worked on a solution in this area. So let me back up here in that, if you think of your last safety incident that you had in a plant, were people in the right zones? Was there an emergency in the facility where time is critical? Do you know where the people are? And can people send a request for help as well? So you can see here the statistics on the different incidents for personnel safety. Falls, slips, and trips are the big one. Overexertion, bodily reaction. But then when you get into situations like fires and hazardous environments and so forth, those are smaller, but probably a lot more critical. Well, they're all critical, actually. So our vision for this is to monitor, where the people are in the plant, but then how many people are in the plant, where they are, and then also monitor things in the plant like safety showers, gas detectors, wind sensors, TV systems. So you get a real good handle on where everybody is in the facility. Okay, so the way that we do that, our particular solution for that is we use wireless HART with these personnel tags that you wear on a lanyard or clipped onto your shirt. And then we put anchors around the plant which will physically monitor the location of where that personnel tag is. So wherever the person is, those anchors are mounted all around the plant in different locations. And then you get a very accurate input as to where people are in the plant. And this technology is shown to be much more cost effective to monitor these critical areas. And then there's an interface as well, so I kind of skipped that. The interface allows you to look at where all the people are in the plant, so you always know where everybody is. Okay. All right, so we've done some advancements in the software side of this solution. Okay, so we have the traditional geofencing and monitoring, knowing where the contractors are. We've got the safety mustering. So in an emergency, you know where all the people are and where they need to go. Are they in the proper locations? And then safety alerts for fallen personnel and so forth. We've added some additional capabilities recently. And this was really a lot around contractor management. So being able to note when people are not moving around, so that if somebody has had a problem and is in the plant and not moving, this software will help pick that up. And so we can look at, are people moving around? Are they in the right locations? And then you can manage that from a central location with the software in the solution. So we'll probably bring this some of this software to the 4C conference that's coming up in August, and we can show it to you. But it's a very unique solution. We've had a lot of success with it. So just in summary of that one is providing a safer work environment for personnel and lowering the response time during an emergency. So there's something wrong and you can get where the people are. They're all accounted for and you can get to them very easily. Okay. So that's the end of that. Okay, so the call to action, this is the final slide. We'll take some questions from you if you have any. But if you have more questions on this or any of the other things, there's a couple ways you can get a hold of us. You can go on our website, emerson.com, Refining Safety, and you click on Consultant Expert. You can type in your email, ask a question. If you want to contact us directly, you could email me. But most of all, come to the conference. There's going to be a lot of good information at the conference that's coming up. So that's what I had. Did we get any questions?
Ed, I cannot believe something that you just showed me. It's the silos between safety and environmental. Just this morning, I talked to a customer that was asking about B1 sampling from a tank. So can you go back to the one that measured the density of the water draw off of a tank for sampling?
Yep.
Okay, this is a perfect example of how digital transformation takes things that were safety and puts them into the environmental world, and that were an operation, maybe not even on operations radar. But because of the digital transformation, this environmental health, safety, and operations and maintenance, they all have to come together. This is a prime example. So a customer called me this morning about B1 sampling for a tank water draw, which it's a crapshoot. The regulation makes no sense because a water draw, as what your thing is showing here, at the beginning, it's all water. At the end, it's a bunch of hydrocarbon. So what's the benzene concentration? Well, it's a curve. It's not a single number. Okay. But that's not even what matters. That's not what's important. What they can do for a crude tank is install your Coriolis with the density control and don't pump that to the sewer. Pump it back up into the oil because they're adding water at the desalter anyway. The only reason a crude tank has a water draw is because all the other tanks traditionally had a water draw. So every crude tank should not have a water draw that goes to the sewer because it has a magnificent amount of benzene emissions that are horrible for the worker exposure and the environment. Instead, they should pump this around to the crude, back into the crude. So see that water, that line off the water that goes down? That can go up, back into the crude. So the water draw off of a crude tank doesn't have to be dumped into the sewer. It can be pumped right back into the oil. Then there's no need for sampling because it's not a waste. It's in process recycle and it goes away. So it goes away as a waste stream. So you have an increase in, it's better for the environment. You have fewer emissions. You have lower load on your wastewater tank. You have less exposure from a health and safety perspective for the person doing the sampling or the person doing the water draw. The old water draws off of a crude tank that were done manually, that's a benzene exposure nightmare. I did that early in my career. I was a benzene expert, and I collected many benzene samples off of water draws off of tanks. And it has too much benzene. You don't really want to do this. You really want to pump this back up into the crude oil for a crude oil tank. That gets rid of the emissions. So it reduces the load on your bugs in your wastewater system. It reduces the emissions. It reduces the worker exposure, right? It maintains a more constant level of water in the oil. You can measure it. You can see that density and gather that data over time and see how that impacts. And I know that one major refiner does this already. They pump the water off of their crude tank and back up into the crude tank, and they don't send it to the wastewater treatment plant. So it's not a theory, it's a proof of concept. It's already been done, but not all the refining companies do it. Because I know I just talked to one this morning and I told him, hey, why are you even wasting the water off your crude tank? Why don't you pump it back up around? And he was like, oh my gosh, that's going to save me a ton of money, because he was worried about going over 10. So this doesn't contribute to your tab in B1 talk, which all it really matters is this is a perfect example of how safety in the past was separate from environmental, which was separate from operations, separate from maintenance. They can't be separate anymore. The digital transformation brings them all together. That's the optimization. That's where these teams have to come together in terms of solutions. It's the same with vibration, with corrosion. Leaks occur in part because of corrosion. Explosions occur because of corrosion under insulation. Whereas the old systems of manually looking for leaks on an inspection, whereas the new systems detect the leak through measurement and sensing. So if the leak is under insulation, they still find it. Whereas the regulations have an exemption for measuring under insulation because the method 21 requires that you circumnavigate the valve or the pump or the flange or the connection. since you can't do that if it's under insulation, it's exempt from monitoring. Well, that doesn't make any sense. If it leaks, it causes corrosion, it'll still cause a safety and environmental hazard. Why not use measurement and sensing to look for VOC concentrations and tell you anytime there is a leak? So this is an incredible example of how measurement and sensing brings all of it together. And this is an amazing product. This product right here will save lives because it'll reduce the benzene exposure. Every time someone does a water draw off the tank, there's some level of benzene exposure. This thing, you don't need that anymore. You just pump this around and this measurement and sensing. The other thing I wanted to point out in terms of the digital transformation, how all of this ties in is measurement and sensing. The measurements themselves, the sensors themselves have dropped in price so tremendously. You're still going to spend money, as you said, and as you pointed out very eloquently, instead of spending time doing inspections, you spend time figuring out what the measurement and sensing is telling you. So you're actually analyzing data, not collecting data. The more time you have to analyze the data, plus anything that's done on a piece of paper, it met the requirement for the inspection. It may never see the light of day. No one may ever look at that data. Whereas measurement and sensing, especially the digital transformation of measurement and sensing, where we can see this data is all available. This data is available to multiple groups. A hard copy inspection done for a safety purpose is never seen by environmental or operations or maintenance. So this whole digital transformation, it really will change all of our lives, but it requires a lot of collaboration. It requires collaboration between safety people and environmental people. And then environmental people and safety people have oftentimes kind of been on the, okay, we do environmental safety. We don't get into maintenance and we don't get into process. That's, that's for the maintenance department and the process operators and the engineering department. And those walls, those barriers, those silos, they really come down during digital transformation because all this information is available to all the parties. And I mean, it's really a great thing that Emerson is doing. This whole suite of products that will be going over the next 3 days, they transform workers from safety. They transform the safety and the occupational exposure, but they also transform what's happening in the community, because every emission that occurs inside of a plant, eventually the wind carries that over to the community, and that's where it becomes an environmental justice issue. So every time a piece of equipment fails, and that is an emission event, that is a potential safety issue. All of this measurement and sensing you're doing reduces the number of incidents, the magnitude of the incident, so it improves safety, but it also improves the emissions, reduces the emissions, both from the worker exposure perspective and from the community perspective. So it's the work that y'all are doing is really, really important. It's really amazing. It's great stuff. And now the challenge is to bring these people together and to drive that collaboration, to get these folks in the same place, to get the safety people to come to the environmental conference, and to get the environmental people to go to the safety conference and realize that they're all really the same thing. Like, this product is probably one of the most clear examples of, look at the benefit to the environment. this water's not going to the wastewater plant. It's going to the back into the oil, because the oil coming off of here goes to the desalter. They add water at the desalter anyway. They want water, and they have to have water in the oil to pull the salt out. So they're adding water. There's no reason to not to just pump this right back around into that same tank. You reduce water level. But when you do that, you also reduce the worker exposure from an occupational safety perspective. So this thing improves the safety, reduces emissions, saves money, all the things that you need to do to be a top quartile, whether you're on for the Solomon Index, or whether you just want to be top quartile within your industry. This is an amazing example of a technology that meets these digital transformation requirements. Okay, sorry to go off on that, but it was such an amazing example, and it feeds into our system exactly. This is what the 4C conference is all about, and this is what makes Emerson great, is this type of product that fills that triumvirate: reduce emissions, improve safety, reduce cost. If it does all three of those things, that's what we want. Those are the technologies we want at the conference, and those are the technologies that have to be implemented across our refining and chemical space, if nothing else, just as an existential environment. The public has to see that we are doing the right things, that we're doing better. Our industry is doing better, that we care about the environment, we care about safety, we care about the community every bit as much as anyone else in the public, or far more. So this kind of amazing technology. How long has this technology been around?
Oh, wow. Long time.
Long time.
Now, whether these applications were being used originally, not so sure, but it's been around for a very long time. It's the applications that people develop over time.
Yeah, it could be that this would have been prohibitively expensive 10 years ago or 20 years ago,
Right.
but the cost of measurement and sensing has gone down. Yeah, the first semiconductor was a lot more expensive than the 20 billion that they made yesterday. Yeah, so this is an amazing example of digital transformation. And every refinery in the United States, I could sell this to every refinery in the United States. This ought to be on every single crude oil tank in the United States. There's no reason you would not want to do anything other than this solution. And a customer called me this morning with an issue related to sampling of the water draw off a crude oil tank. So I know they're still taking water draws off of crude oil tanks. Some companies are. I told him to not do this, not to do the sampling anymore, to pump this around. But I didn't know about your device. So I'll tell you who it was after the call. I'm sure they're going to be very interested in buying this, because after I told him, hey, why are you doing the water draw? Why don't you just pump it back onto the tank? Pump the water back into the crude oil tank. He's like, never heard of doing that. And I know a major refiner does it at all their refiners, so I know it works. But yes, this is a great example of digital transformation leading the way into the future. And I know you guys have a whole suite of products, every one of which do the same type of thing. They reduce emissions, they improve safety, and they lower cost. And, you know, I'm just super happy that I'm able to work with y'all and that we can, you know, lead the world to a better place, reducing these emissions, improving safety, and lowering cost and making this great country more competitive. Okay, thank you very, very much for your time. And thank you for those attended and for whoever's watching this webinar for years in the future. Thank you for watching our webinar. And with that, we'll end today's session. Thank you very much and take care.
Thank you.